All right, so we're moving on to the last section of this chapter, and that is section E, and it's going to be problem solving, and this is going to be dealing with word problems, all right? So it's going to be word problems, or I will just already have an image drawn for you, but it'll be some kind of real-life application for this. And you'll see it's going to be exactly similar to some of the things that we've been doing with using similar triangles to solve for missing sides. It's just now it's not going to be just triangles that we don't know what they represent, but it's going to represent something actual going on around us in the world, or something that we could use to solve. So our objective is to draw similar triangles when given a word problem and solve. Sometimes you have to draw them, sometimes you won't. Sometimes the images will be drawn for you already, but if they're not, you will need to draw them. And then the other thing is we will have to solve the word problems. We'll have to figure them out. All right, one of the things that you have to be able to realize is if we have a vertical line and a horizontal line, right? Anytime we have a vertical and a horizontal line, they are perpendicular, so it will create this right angle. So if you think about this, if I say that we have a building, and here's the building, and it's into the ground, these are going to create right angles with the ground. So when we're talking about a building, if I say that a person is standing there, this person standing on the ground is also perpendicular to the ground, right? Because when you're standing straight up, you're vertical and the ground is horizontal underneath you, so it's going to also create a right angle. If we say that we have a light post that is put it into the ground, then we know that this is also going to be a vertical angle as well. I'm sorry, it's going to also be perpendicular as well. So that's one of the things that you have to be able to realize when you're solving some of these questions is when I'm telling you find the height of a telephone pole when given its shadow, you need to know that that telephone pole is perpendicular to the ground, right? That's one of the things that you must be able to know. All right, let's go ahead and talk about how you'll solve these, and then we're going to just do 2 questions in this video, and then that's it. All right, to solve problems using similar triangles, we follow these steps. 1, sketch the situation. So if I don't already give you the drawing or the image, then you need to draw it yourself. Because without having these triangles drawn, it's going to be really difficult for you to figure out how we set it up and how to solve. And then also, after you sketch it, you must show all the given information. Fill it all out, everything that you know. And then whatever it is that you're trying to solve for, use a variable to represent it. So x to represent the unknown quantity to be found. You can use any variable you want, though. It does not have to be x. And then establish that a pair of triangles are similar. So we're going to be looking to see which triangles are similar. Once we say that they're similar, then we will set up an equation to solve for the variable. And then we will solve the equation, and then you will answer the question in a sentence. All right, so you're going to draw it, fill in all the information, figure out what you're trying to solve for, solve it, and then give me the answer in a sentence. All right, so let's go ahead and solve a couple questions. All right, so for this problem, it says, one sunny morning, Fan and Kuyen compare the length of a shadow of their school hall with that of a 1-meter ruler. The measurements are shown in a diagram. So here's their school. Oops. Here's their school. Here's the ground. We know that this school is going to be perpendicular to the ground. So we know that it creates this right angle. Right? When the sun is shining, let me see if I can change this in color really quick. When the sun is shining, let me make one that might be a little bit easier. When the sun is shining, if we can imagine that we can actually see the sun rays, then we can imagine it being this straight line here. So it actually forms this triangle. Right? So it forms this triangle with the building. And our shadow is this here on the ground. Right? Then they took a 1-meter ruler stick and they put that in the ground. And they said, okay, well, what is this shadow going to be? Now remember, the same thing. When they hold this up, that creates a right angle as well. And then this one creates this triangle here. So what you have to realize is this creates two similar triangles. And we know this through angle, because both of them share this angle here where both of the shadows are meeting at the exact same place. So both shadows are ending at the same place. So they share this angle here, and both of these are 90 degrees. So that means we have 2 angles that are congruent. So through angle, I know that these triangles are going to be similar. Right? And now if you notice, we say that our shadow over 1 meter ruler stick was 1.2 meters, and it tells us that the shadow of the building is 24 meters. Well, we want to know how tall is the building. So now remember, when these, I'm going to put H for our height. When we have these triangles that are embedded in one another, we don't need to worry about twisting and turning. The sides that appear to be corresponding are. So that means the height of the building corresponds with the height of the meter stick. So I'm going to put H, because I don't know what the height of the building is, over 1, because that's what the height of the meter stick was. And now remember, we have to stay consistent. So since I did the school in my numerator, I need to do the shadow of the school in my numerator as well. So that would be 24. And then over the shadow of the meter stick, so 1.2. And now we set this up, and you should be able to solve this by now. We will cross multiply. So 1.2 is then equal to 1.2h is then equal to 24. We will then do 24 divided by 1.2. And our h is then equal to 20. So we would have to write this out as a sentence. So what we were solving for is the height of the school. So we would say the height of the school is 20 meters. All right, now there's one other question that we're going to go through, and then we're done with this video. All right, the last type of question we're going to go through is where I don't give you any image, and we have to draw this. So it says a tree 24 feet tall casts a shadow. So let's go ahead and draw this tree real quick. So here's our tree. And we know that it is 24 feet tall. So I'm going to put this line here, and I will put 24 next to it. It casts a shadow. And there's our shadow on the ground. And it says that our shadow is 12 feet long. So I'm going to put this in green just so that way we can, or I'll also put this as well. So it's 24 feet long, or 12 feet long. We know that the tree is perpendicular to the ground. All right, then it says Brad is 6 feet tall. How long is Brad's shadow? So let's just imagine that Brad is standing here. Right, and we know that Brad is 6 feet tall. And now we want to know how tall is Brad's shadow. All right, so now we want to know how tall is Brad's shadow. And Brad's shadow would be this portion. So I'm going to put S for shadow. So S represents Brad's shadow. All right, now I'm going to go ahead. I have two similar triangles because when Brad is standing here, it's also going to create a right angle. So through angle, I know I have two similar triangles. So I'm going to now just make sure I do the corresponding part. So the height of the tree, 24, over the height of Brad, 6, is then going to be equal, since a tree was in our numerator, the shadow of the tree needs to be in the numerator as well, over the shadow of Brad. So now we can go ahead and simplify. 24 over 6 reduces to 4 over 1. We can then go ahead and cross multiply. So 4s is then equal to 12. We can then divide by 4. And his shadow is equal to 3. So Brad's shadow is 3 feet. All right, that is it for this video. And that's it for this chapter.